So let's consider the IUPAC rules for naming carboxylic acids and derivatives. So first, carboxylic acids are named by replacing the E in the parent alkane. So the E in the parent alkane is actually replaced by oic and the word acid. So for instance, if I have CH3 CH2 COOH, so notice that this is a 3-carbon compound, and as such the corresponding alkane should be propane. But in this case, I'll go ahead and call this a propanoic acid. So notice that the E here was replaced with OIC and then the word acid added. So next, when naming compounds containing alkyl groups, hydroxyl groups, halogen substituents in addition to carboxylic acid, the carboxylic group is given the lowest possible number and it takes the parent name. For instance, if I have a compound like this, now you notice that in this compound, if I should name from 1, 2, 3, 4, 5, now it means now you notice that from this compound, if I should name from 1, 2, 3, and 4, it means that this area, which is my carboxylic acid, will actually become the carbon 4. But if I should name in the other way around, let's say from 1, 2, 3, 4. Now you notice that my carboxylic acid here will be at carbon 1. So that's our ultimate goal, to make the carboxylic acid appear as the lowest number as possible. So over here, which is my carboxylic acid group, should be my preference. So I'll have here as 1, I'll have here as 2, I'll have here as 3, and I'll have here as 4. Now notice that I also have a methyl group here. Now from the rule, my carboxylic acid should have preference over the methyl group. So with this, I have my carboxylic acid at carbon 1 and then my methyl group as carbon 3. So if I want to name this compound, this is methyl group, this is methyl here. So I have my 3 methyl, and this is a 4-carbon alkane, which is butane, right? But in this case, I'll have to call it a butanoic acid because of the COOH, or because of the carboxylic acid group, so it becomes butanoic acid. So this is 3-methyl butanoic acid. So let's go ahead and wipe this and see the next example. Alright, so if I have this way, perhaps this is my O and this is OH. Here I have chlorine, and over here I have OH, and then here I have CH3. Now remember, according to my rule, that I have to put or keep my carboxylic acid in preference. So I'll have here 1, I'll have here 2, I'll have here 3, I'll have here 4, I'll have here 5, and I'll have here 6. So this is 1, 2, 3, 4, 5, 6. So if I should have a structure like this, now this is chlorine here, and this is a hydroxy here. So chlorine is at carbon 3, while the hydroxyl is at carbon 4. So I'll name this way: 3-chloro, 4-hydroxy, now this is a 6-carbon alkane here, which is simply a hexane. So in this case, it is having a carboxylic acid group, so I call it a hexanoic acid. So hexanoic acid. So this is the name for this compound. Alright, so I'll go ahead and see the next rule. So the next rule here is the prefix di is used for compounds containing more than one carboxylic acid group. Example, if I should have so notice that I have a carboxylic acid group here, and I have a carboxylic acid group here. Now I have 3 carbons all together, which is a prop, right? So I can name this compound as a propan dioic acid. Oh wow. So this compound is propane-dioic acid. So I'll go ahead and state the next rule. So we said here, aromatic carboxylic acids are named similarly. For instance, if I should have this, and I have so if I have a double bond here, and I have a double bond here, and I have a double bond here, what structure is this? This here is benzene, and then this is a carboxylic acid. So I can simply call this a benzoic acid. Yeah. Alright, so what if I had a chlorine here, and then and NO2 here, that's the nitro. So if I want to name this compound, first of all, I'll put this as priority, and then I'll name this as carbon 1. So this becomes carbon 2, this is 3, this is 4, this is 5, and this is 6. Because I know that if I start with this, that's correct, right? But if I go this way, 1, 2, 3, 4, 5, now the substituents will have higher numbers. So if I should go this way, this should be the correct movement for this. So I will have chloro at carbon 2 and nitro at carbon 4. So I will simply state this as 2 chloro for nitro benzoic acid. So that's the correct name for this compound. So next I'll look at one other example, and then we consider the esters. So let's also check this out. If I have this, so what structure is this? This is a benzene ring, and if I should add this, now this is an ethanoic acid, so I can choose to name this compound based on the ethanoic acid here. So I can simply call this a phenyl ethanoic acid. So which is an ethanoic acid with a phenyl group. So this is simply how I can name this compound. Alright, next let's consider the esters. So esters are still carboxylic acid derivatives. So I'll go ahead and check out some work examples using esters. So for instance, if I should have so what's this? Our popular benzene ring. So let's say I have my COO, and then I have CH3, and then I have my nitro here. So what compound is this? Alright, so in order for me to name this, I'll have to put my functional group as priority here, because this is where I have my ester COO. So I'll have to state this as carbon 1. So this becomes carbon 2, this carbon 3, this carbon 4, this carbon 5, and this is carbon 6. So if I state this way, whether I go this way or I go this way, the nitro will still be at carbon 4. So now notice that I have a methyl group here, so I can simply call this methyl 4-nitro 4-nitro benzoates. So my esters, instead of having oic acid, I'll have OAT. So I have my oic acids translated to OAT. So I'll pick another example and then we'll try it out together. If I have this CH3 CO O, and then I can put this up and yeah. So this is the nitro, and this compound is the same as the previous compound I just showed on the last screen. So this is the functional group. I'll take it as 1, and then this becomes 2, this becomes 3, this becomes 4, this becomes 5, this becomes 6. So I call this, I'll have my methyl group here, so I call this methyl 4-nitro benzoate. Now there is also another way to name this compound, and that's naming from the ethanoic acid here. So, and it becomes more simpler to name from the ethanoids here, because we can actually look at these and look at these and then consider these as a derivative and consider these as a substituent. So when we do that, we'll have, this is at carbon 1, so this is 1, 2, 3, 4. So I'll have 4 nitro. So I'll name these as phenyl. So phenyl ethanoids. So this is the correct name for this compound. So this is another way we can name this compound. So I'll go ahead and wipe this off. So lastly, if I have CH3 CH NH2, then C OO, and then CH2, and then CH3. So let's recall that our major interest should be on our functional group here, which is the ester here. So if I take this, and from here I have 1, 2, and 3. So, or let's say 1, 2, and 3. So, whereas this is an ethyl, so I can simply say this is an ethyl group combined with an amino ester. So over here I can call this ethyl 2 amino, and what's alkane has 3 carbons, that's propane, and in this case it is an ester, so we'll call it a propanoid. So I have ethyl 2 amino propanoids. So this is how I can simply name this compound. So next, let's consider the acid anhydrides. So symmetric acid anhydrides are named by replacing the acid in the corresponding carboxylic acid with anhydride. For instance, if I should have this structure, let's say CH3, CH2, CH2, COO, CO, then CH2, CH2, and CH3. So I can simply name this compound as propanoic. I can simply name this compound as butanoic anhydride. So this is how I can simply name this compound. Now the reason is I have a butanoic acid, that's 1, 2, 3, 4 here. Then I have 1, 2, 3, 4 here. So this makes it a butanoic acid, a butanoic anhydride, because they are actually symmetric. So this is corresponding to this. Alright, so having known that, let's look at other examples too. So let's say I have CH3 and then I have COO and then I have COO and then I have CH3. So what's this structure? As simple as it can be, this is ethanoic anhydride. So let's look at another example too. So let's say we have C6H5 and then we have COO and then we have COO and then we have C6H5. Now what's this? This is a benzoic anhydride. So here I have a benzoic anhydride because this is a benzoic acid and this is a benzoic acid. So together I have a benzoic anhydride. Alright, so let's consider the next example. Let's say I have CH3, CH2, COO, COO, then CH2 and CH3. What's this? 1, 2, 3, and then this is 1, 2, 3. So this is propanoic anhydride. So this is simply how we can name the anhydride if they are symmetrical. So what if they are non-symmetrical? So for unsymmetrical acid anhydrides, they are named by naming each component of the carboxylic acid alphabetically, followed by a space and then word, and then the word anhydride. I'll go again. The unsymmetric acid anhydride are named by naming each component carboxylic acid alphabetically and then followed by a space and then okay, let me take that for the last time. Unsymmetric anhydrides are named actually by naming each component carboxylic acid alphabetically, followed by a space after each. Then the name anhydride is written at the end. So they can be called mixed anhydride. So for instance, if I have CH3, I have okay, let's go this way, and then so notice that over here I have a benzoic acid and over here I have an ethanoic acid. So since this is an acid anhydride, I'll simply pick these both and then check the first letters. B comes before an E, so I'll have to place B before the E. So I'll arrange them alphabetically. Let's say, so I'll arrange them alphabetically. Let's say benzoic ethanoic anhydride. So notice that I have a space between these. So, and then notice also that my B here comes before E, and then at the end I'll add anhydride. So let's look at another example on that for clarity. So let's say I have CH3, CH2, then this, and then CH2, and then CH3. So this is 1 plus 3, 4, 5. So what's this? This is pentanoic acid. So this is pentanoic acid because this CH2 into 3, that's plus this, that's 4, then plus this, that's 5. So this is pentanoic acid, while over here this is 1, 2, 3. So this is propanoic acid. So notice that this is P and this is also P, but PE comes first before PR. So I'll go ahead and write this as pentanoic propanoic anhydride. So this is basically how we can name our anhydrides. So the next is we'll check out amides. So for the amides, primary amides are named by replacing the oic acid in carboxylic acid with the word amide, or replacing the E in a parent chain alkane with amide. So let's take this example. If I have CH3, CH2, CONH2. So this is 1, 2, 3. So if I had an alkane, this would have been a propane. But then for the amide here, since 3 is prop, I'll have this as propan amide, and this is simply achieved by removing or replacing the E in the propane with the word amide. So this is propanamide. Alright, so also secondary amides are named by using the uppercase letter N to indicate that the alkyl group is on the nitrogen atom. So for instance, if I have CH3, CH2, CONH, CH3. So I can name this as N methyl propanamide. So this is the simple way to name this. So this is 1, 2, and 3, the third carbon. So that's a propane added to this, the amide, and then I have methyl attached to it, so I call it N-methyl propanamide. So also tertiary amides are named in the same way as the secondary amides, with NN indicating number of alkyl groups. So for instance, if I have CH and I have O here, so I have N bonded to 2 alkyl groups. I'll name these as NN dimethyl, because I have 2 methyl groups here, and then I have just 1 carbon, So this is a methane, so I call it methanamide. Wow. So this is how simple it can be. And next we'll simply go over to the IUPAC rules for naming amines and nitroalkanes. So amines are named by attaching the suffix amine to the alkyl substituents, such as you can have maybe methyl amine, we can have ethyl amine, we can have propyl amine, and so on. So you can also use the prefix amino to the alkane. So let's say, for instance, we can have amino methane, we can have amino ethane, we can have amino propane, you can have amino butane, and so on. So let's quickly run up with an example. Let's say this structure CH3 CH2, okay, CH2 NH2. So this structure can be named in two different ways, just like I've stated earlier. We can actually call this ethyl amine because I have 1, 2 carbon, so I can name it from the alkyl group, so call this an ethyl amine. Or I can also name this as an alkane group, but then call this amino, so it becomes amino ethane. So basically this is how I can name this compound. So the next rule, secondary and tertiary amines are named like others. The alkyl groups attached to the nitrogen are placed in alphabetical order with no space between them. So let's say if I should have CH3 CH2 and then NH CH3. So with this, I know I have a methyl here and I have an ethyl here and I have my amine in between. So this is a methyl, this is an ethyl. Now I have to actually write this in alphabetical order, so naturally E comes before an M, so I'll name this as an ethyl methyl amine. Or I can also use the alkane to name this. If I name this following the alkanes, I'll name this as ethane, and then this as methane. So naturally I'll have this to be ethane amino So naturally, when I want to name this using this, I'll now name this first as a substituent and then notice that I'll now name this as a substituent and then notice that when it becomes a substituent, I'll call it an alkyl. So this becomes ethyl amino methane. Alright, so let's look at another example. Let's say I have CH3, CH2, CH2, and CH3, 2. So this is a dimethyl, and then over here I have a propyl. So I can simply go ahead and name this dimethyl propyl amine. So notice that I wrote dimethyl first before propyl because D comes before P. Likewise, I can also write this to be in the alkane form, and then absolutely I can call this a propane, while this remains dimethyl. So I'll simply name this compound as dimethyl because this comes first, so I'll use this as a substituent. So dimethyl, and then I'll call this amino propane. So this is how we can simply name this compound. So let's check the third rule. Now the carbon bearing the amino group is assigned the lowest possible number. For instance, if I should have this NH2 CH3 CH3, so if I number this way, 1, 2, 3, and 4, notice that my amino group will be at carbon 3. But if I number this from here, 1, 2, 3, and 4, now my amino group will be at carbon 2. So I want to number it in a way that my amino group will have the lowest possible number, which is here at carbon 2. So I can simply name this compound as 2-amino, and this is 1, 2, 3, 4 alkane. So this is a 4-carbon alkane, and what's that? A butane, right? So I call this 2-amino butane. So for nitroalkanes, the carbon bearing the nitro group is assigned the lowest possible numbers. So two systems are used for naming nitriles. Two systems are used for naming nitriles. Number one, they can be named as alkyl cyanides. For instance, I can have CH3 C triple bonded to N, and I can call this a methyl cyanide. They can also be named from an alkane, where this same structure CH3 C triple bonded to N can be called cyanomethane. Alright, so in the second system, the carbon atom of the cyano group is considered as carbon 1. So in the second system, the carbon atom of the cyano group is considered as carbon 1 of the alkane carbon chain. Then the word nitrile is added as a suffix to the name of the alkane chain. For instance, the previous example we just used, which is this, that's the methyl cyanide or cyanomethane, can as well be called an ethane nitrile, where this is considered as carbon 1 and then we'll call this carbon 2. So this becomes 2 carbon molecule, and this is called an ethane cyanide. So for this structure, what will be the name of this compound? All right, so this will be carbon 1, this will be carbon 2, this will be carbon 3, and then this is propane, right? Propane nitrile. So as simple as that. So let's consider this. If I have C6H5CN, now I can possibly name this as benzonitrile, or I can name this as phenyl cyanide. Alright, so let's look at the IUPAC rules for naming thiols and thioesters. So ordinary compounds having the thiol groups at carbon 1 can be named by adding the suffix thiol. For instance, if I should have CH3, CH2, CHSH. So this is the thiol at carbon 1, and I can simply go ahead and name this as propane thiol. So notice that I have 1, 2, 3 carbons, and this is a 3 carbon alkane, which is the propane, and then I have the SH group at carbon 1, so I can call this 1 propane thiol. As well, I can also have CH3, CH2, SH, and this is 1, 2 carbons, so I can call this an ethane thiol. So if a thiol is a substituent, it can be called as mercapto. So let's use this as an example. And then also recall that we want to possibly give the lowest possible number to the carbon bearing the thiol group. So if I count from here, 1, 2, 3, 4, 5, and 6. This will give me the thiol group at carbon 4 here. So if I go ahead and count from this side, I'll have 1, 2, 3, 4, 5, 6. So this will give me the thiol at carbon 3. Now I want to use this because this gives me the thiol as at the lowest possible number. So I can simply go ahead and call this 3 mercapto. And what structure is this? What alkane structure is this? This is a 6 carbon alkane, which is a hexane. So I can call this 3 mercapto hexane. So let's go ahead and wipe this. So symmetrical thioesters are named by attaching the prefix di to the alkyl substituents, followed by a space between the word sulfide. So let's take, for instance, if I have CH3 CH2 S CH2 and CH3. So I have the first alkyl group here, and I have another alkyl group here. So what alkyl is this? This is an ethyl, and it's symmetrical to this, so this is an ethyl. So I can simply add the word di and then ethyl, and then at the end I put the word sulfide. So as simple as that. So next, unsymmetrical thioesters are named by naming each of the alkyl substituents alphabetically before the word sulfide, so separating each word with a space. For instance, if I have CH3 CH2 as CH3, now notice that this is unsymmetrical because this is a methyl and then this is an ethyl. So if I should arrange this alphabetically, E should come before an M. So I'll have ethyl, methyl, sulfide. So that is it. So this will be the end of this lesson. I hope you enjoyed this video. Please, if you do, give it a thumbs up. Also share with your friends and subscribe to our channel. Thank you.